So welcome to lecture number 10. We're going to talk about, we'd like to develop this theory of an endogenous wage distribution, and this will be motivated by what we did last week. So I'll have to spend some time thinking about that. Again, maybe reviewing some of the ideas that we developed. The idea would be to develop a model for the offered distribution. And this is not a trivial problem. Okay, and we'll talk about the diamond paradox, which has nothing to do with diamonds, has to do with Peter Diamond, who was the economist who came up with this paradox. And this means that we've been taking this F as given for the worker, but it's not really clear where it comes from. And if it doesn't come from any sort of sensible model of an equilibrium, then it doesn't make sense to talk about it. So, and we'll talk about that. And then we'll talk about some ways of motivating an endogenous wage distribution, because if you do that, you need to have someone in charge of setting the wage. Someone actually has to decide to set a wage or determine a wage, and we can have lots of theories about that. The competitive theory will not work, because the competitive theory says there's a single wage. And that's kind of what the diamond paradox is all about. Now, one way of doing this would be to think hard about the job search model, and that's why this paper is very important, not the Rogerson-Scheimer-Wright paper, which you already have read, I'm sure. You need to read because it's extremely important, but rather a paper on which a section of this is based, which is a paper by Ken Burdett and Dale Mortensen. Okay, this paper is, I think I mentioned already once, it took 10 years to get published, but it's really, really important because it sort of gives us something we can grab in terms of a foundation for a model of equilibrium wage offer distribution. It's just one version of many different ideas that you can operationalize. The only problem with this paper is that the notation is not great. And they tried very hard to push their notation through. I've got a little translation table that I will post later in case you really want to read the paper. But I'm using the notation that Rogerson-Scheimer-Wright used, which is not the notation that Burdett and Mortensen used. And there's some reasons for that, but keeping in line with the course, it makes sense to use the same symbols. So you'll see what I'm talking about maybe later on. It doesn't really change the substance because that doesn't matter. Come in. So I'm just talking randomly about the plan for the day, so don't worry, you haven't missed anything. So the idea was that one theory that Burdett and Mortensen put forward is that maybe this is an equilibrium in itself where firms are actually posting a wage and accepting the consequences. So the question is, every wage that you might post has a different consequence for your expected profits, and therefore, firms being rational would think about that. And because this world has constant returns to scale, a firm is the same thing as a group of workers working for some randomly defined employer. There's no economies of scale. So you can think of the concentration of work relationships at a given point in the wage distribution as being the size of a firm. You can either think of it as the size of a firm, or the height of the density, or the height of the density, the number of firms that actually exist in equilibrium at that size, or the number of workers at a single firm paying that wage. So there's just two different ways and there's no way that we can distinguish them in this model. So if you want to add firm size, you can, but that changes the complexity of the model, but it doesn't really change most of the most important messages of this setup. And this will give us maybe some input into directed search. Maybe I'll talk about that a little bit, but we'll probably end up spending the next hour also finishing up this model, because it's fairly important and fairly complicated. So last time we looked at the on-the-job search extension to the on-the-job productivity shift model. And we saw that some of some of the conclusions that that came from that model kind of carry through. There's a certain ability of the workers to turn down unattractive offers on the job search model, which makes it a bit more interesting. The worker can always separate from the firm in the other model, but there will be wage cuts involved. And that's because the wage is just equal to productivity in that model, which is kind of a problem, I think, because productivity may be very hard to measure. It may be private information for the employer, and maybe the worker also has some private information, so it's not really clear how that should work out in the end. So take it slowly. We'll take the job relationship in a wage posting context as the next extension, and that will give us the ability to implement Burdett Mortensen. Okay, so that means that, going very slowly, last time we looked at F as the primitive, and then noticed that some jobs would never pay wages that have a certain shape that relative to the F distribution, the offer distribution. In fact, the accepted wage distribution has to stochastically dominate, first order, the offer distribution. So that gives us kind of a hint as to how we're going to proceed. Think of the model as we've derived it as kind of offering us one direction of causation going from F to G, and if G is what we actually observe, maybe we could even tweak the model to generate some causation going from G to F. And then we can have two equations in two functional equations in two functions, and we can actually derive the F as well as the G. So that's the big yay moment, progress. But let's review what we did. But those of you who didn't make it last time, or maybe just didn't remember what we did, you really do need to read Rogerson, Scheimer, Wright, but maybe take a look at the Burdett Mortensen paper, because it's written kind of in a different tone than the review paper that we've been looking at so much in this paper. So we've started with a continuous time setup, and workers have this indifference condition between remaining unemployed and searching, except now when you get a job, you have an option, you have sort of the alternative. Turning down this offer means turning down the chance of getting a raise, not necessarily inside the company, because the company is not being modeled here, but in the employment relationship, you might get a raise in the sense that another firm comes and offers you a better job, and that pulls you up the distribution. So that can be also thought of in the context of a single firm, but we're not going to do that here. So we're thinking of just basically moving across the distribution. And it has very strong similarities with the productivity analysis that we did before that. And risk-neutral agents can consider this, take this seriously as an unemployed person. It makes the job potentially more attractive because it means that you can always move up this sort of pay ladder, and rejecting an offer has no consequences. So you can always turn down lousy job offers. If someone comes up to you and says, hey, you want to work at this terrible job, you can just ignore it. Okay, so that's really interesting. It shows sort of conditions what we're going to observe in the real world. So we asked the same questions before. And we derived that wage, and it looked a little bit different. Obviously, it has this new piece in the denominator, which involves this arrival rate of an on-the-job offer. And remember, these offers are assumed in this model to have the same underlying distribution. So you're getting the same offer distribution if you're unemployed or if you're on the job. The only difference is the frequency, summarized by the Poisson parameter, could be different. And that's just an assumption of the model. You could indeed have different distributions, but we know from our previous lectures that leads to a lot of complexity, and you can't reduce this in a very simple way. Okay, not to say that it's wrong, but again, we want to get the intuition first. Okay, any questions? Right. Okay, so this is actually in the paper. I mean, it collapses to a similar equation of the standard model that we've spent the whole half a year looking at, if you let the arrival rate on the job go to 0. okay? So there are all sorts of interesting tricks. We have the same intuition that alpha 0, alpha 1 are kind of, it's the contest. The most important reduction of the complexity of the model is the arrival rate. So if it's the case that actually you get more action when you're an unemployed person, and you can always tell a story to rationalize that, then you'd expect the reservation wage to be higher than the income equivalent when you're unemployed. On the other hand, if you get more offers when you're on the job from the same distribution, it's definitely more attractive. And the reservation wage will be below the unemployment income. So that's an interesting contradiction to this notion, well, you know, people just accept anything that's above what they can get in unemployment insurance income or the like. That's just not right, because there's this dynamic element. Okay, and you can use comparative statics to figure out what you'd expect. The attractiveness or the reservation wage will depend on these underlying parameters, including the underlying distribution of the offered wage. Okay, so now, last time we talked about all the implications this has for quantities, and one was the quantity of unemployed people, because people who are unemployed leave unemployed if they get an offer that is more attractive than the reservation wage, and if not, they stay in unemployment rate. And again, assuming everything else, ceteris paribus, all arrivals are identical, workers are identical, and remember, that's the magic of this model, is the workers are the same. I mean, again, we can always cook a model with the distribution of underlying productivity. It's verifiable. When you meet, you can examine the workers' productivity. You can change all that. But that doesn't really, that's almost like assuming more than you need to get this fantastic frictional result. This is based on a friction. Just you cannot get an infinite number of arrivals in any particular period of time, and you can't know where all the jobs are. Okay, so we already know the inflows into unemployment is basically this parameter lambda times the, and again, U star is the equilibrium unemployment rate. So 1 minus U is the equilibrium employment rate measured on the labor force, which is fixed. So be careful. In labor economics, those of you taking my labor course know that the employment ratio is usually based on the civilian population of working age, not the labor force. Labor force means you're looking, so you're either working or you're unemployed and looking, trying to get a job. And people who are discouraged, stille Reserve, they won't be in that set. Okay, so again, this is a two-state model. We don't consider out of the labor force in this setup, so it's just basically, that's it. That's the inflows into unemployment. And the outflows out of unemployment is this arrival rate for the unemployed times the probability that they will get an offer that exceeds their reservation wage, and all workers are the same, so that's a singleton. If you have a world with lots of different types, then people have different labor alternatives or operating in different labor markets, they'll have different reservation wages, obviously, but this is, again, a very, very stripped down model. So multiply that by the equilibrium unemployment rate, and then we have the unemployed flow out of unemployment into gainful employment. Okay? So we could take that difference, would be like du dt, the change of unemployed in the stock, because the stock is the same thing as the rate in this model, because the labor force is equal to 1, right? So it's really easy to think about it. So when that thing is steady, we've got a steady state. We can solve for the unemployment rate, and it looks like that. Okay, so these quantities are going to be very important for us when we derive the distribution later on. Remember, this is S divided by S plus F, but now it's fancy because we've actually derived F in a context. Okay. We also have this new thing, which is job-to-job turnover, which you can observe if you just look at unemployment rates, right? Because it's like, always take the analogy of a lake. The water may be very still in the morning, nothing's happening, but actually underwater is lots happening. Lots of water's moving around, but you just don't see it. fish are moving, swimming, spawning, whatever. So you have this turnover would be moving from one place to another, but not changing the unemployment stock, period. Okay, and that's going to happen. That's part of the story, because that makes possibly getting a job more attractive than it would just appear if you got that job, that wage for the rest of your unemployment experience. You can actually move up the ladder. Now, today we're going to try to use those results to, first off, to identify this distribution of accepted wages. We're going to solve for it, and then we're going to ask, how do firms behave if that's what they face when they look right and left, and they get to post the wage. So first we go slowly, we'll do what we did last time, deriving what G looks like. Okay, so like I said, the theory is very clear. Despite identical workers ex ante, ex post, they'll be working at jobs with different wages because they were lucky. It's all about luck in this model. It's not about skill. So, you know, if you take a Rawlsian view of the world, maybe the minimum wage in this model actually has only good things. It redistributes income because these workers are all the same anyway. The ones that are getting paid badly are just unlucky, right? But that's very special. You know, you have to be careful. Don't take that and put it on your banner and go protest. But it is an interesting implication of the theory. Right. So the reservation wage implies this functional equation, or relationship that takes the offer distribution and puts it into an observed wage distribution that we can talk about. And you know, we can make some observations from the beginning. We know that workers won't, just by construction, they will not accept wages below the reservation wage. That's what reservation wage means. Okay, so we know that the support of G is going to be smaller. And if you have a smaller support and you have an upper bound, then something has to happen in between. Okay, so you know, we can ask this question: if you take any wage on that implied G distribution, what can we say about it? And this is where I tried a little bit too glibly to go through this last time, but I think in the end I saved myself. So if you watched the video from last time, don't just take it with a grain of salt. But I think I actually got it right in the end. Think of the following: if I take any wage, any point on the support, and I take G that's implied by that, which is the mass of workers earning no more than W. That's what the definition of a CDF is. Now, if I can take any point on that support, I can ask questions. How many workers are flowing into the mass of jobs that pay no more than W? Okay, so suppose W is for me is 50 euros an hour. Then I can ask how many workers came into this mass of the distribution paying no more than 50 euros an hour. Now, those people could be coming from outside the unemployment, outside of employment. They could be coming from unemployment. Could they be coming from anywhere else? Well, could they be coming from above 50? No, because they would turn those offers down. So if they get paid less than 50, they're going to be flowing within the CDF, but they're not going to be changing the mass of jobs that pay no more than 50. That's what I was trying to say last time, okay? So we can do that exercise for every point in terms of inflows. We can also figure out what are the flows of workers out of that mass of jobs paying no more than W. Okay, and that's a little more tricky because you can have these exogenous separations that, like lightning hits you from somewhere and then you have to be unemployed. That's the rules of the game. Or you get a job that offers more than 50 euros, and you're going to take that, and you're going to leave the CDF. You're going to leave the area under the density up until 50, just for example. Okay, so we can derive those two objects, and if they're equal, that means that the distribution isn't changing anymore. And if it's true for every W on the support, then we've effectively derived the CDF, okay, of the observed wage distribution given F. So you start with F, put an arrow, moves to G. That's the first operation we're going to do. Later on today, we're going to do we're going to turn around and we're going to go from G to F. But if we do that, we have derived the CDF, the cumulative distribution function for this particular distribution, using the theory. All workers are the same. The only thing that's different is this friction. I mean, it makes workers are different. If they've got a job, they're different. They're going to be different from workers who don't have a job. Workers who don't have a job will be jealous because, conditioned on being in the pool of unemployed, they're going to have a lower expected lifetime income because they're, for that instant of time, possibly for a long time, because if they're unlucky, they'll be a long-term unemployed person. Being long-term unemployed is not a mark on your forehead. It's basically because you've been unlucky in this model. Okay, so now let's try to derive using the objects that we've learned already in the previous lecture. So if asking the question, what is the flow into jobs paying no more than W, then we can ask the unemployed workers who have mass of U star, so the size of the pool of unemployed workers relative to the total, again, it's a fraction, it's just U star. They have to have gotten an offer of a reservation, of an offer of a wage coming from F that exceeds WR. It's just the definition of having a reservation wage, okay? But like I said before, workers coming from elsewhere in the distribution are not going to be relevant for G. If they're coming from below W at any W, they won't change the mass, but they're moving within that lower range. Okay, and then otherwise they're going to be flowing out. They're not going to be flowing in. Okay, so that's a nice little way of summarizing that first piece. So it's going to be alpha 0, the incidence parameter for an arrival if you're unemployed, and then just getting something that's attractive enough to make you leave. Okay? So that's, if you're kind of confused where that comes from, it's 1 minus F of WR minus 1 minus F of W. Yeah. And then if you pass the minus signs and subtract the ones, you get that. Okay? So that's the inflows, and that balances the outflows at every point in W. So it's a functional relationship. We're going to be mapping F into G for every point that's potentially of issue. Okay, so the outflows, as I said, was more complicated because you have this exogenous job destruction, and you get those people who get an attractive offer that pays more than W. Okay, so no matter where you are before, if you get an offer that's above W, then you're going to leave. So you're an outflow out of this CDF, and that's true for all W. Okay, so if you could be being paid less than W, and you get an offer that's attractive, and you change, but you don't leave G of W. So think real hard about that. It's really a clever, very clever derivation. 2 parts, right? It's just by construction. The exogenous job destructions occur like lightning. You get struck by lightning, you go into unemployment. That's the first part. And the second part is you're working, you get this incidence at Poisson intensity alpha 1. The size of the people who are in the CDF that pay no more than W is 1 minus U star, and then you've got this G of W. And then if those people get a better offer, they're going to leave. So it has to be the case that the arrival was greater than W. That's the last piece. Okay? So again, if this distribution is this function, it has to be, the assumption is in a steady state that it's stable, it's not changing. So that means at every point in W, this thing has to be stable. If that's true, then at every point, this equation has to hold. So think of this as a functional equation. It's an equation involving two functions. One is f and one is g. And it's true for every w. And this model is so beautiful because it allows us to solve for g. We can actually solve for it. Not always the case, probably. And generally it's not the case. And in this case, you can solve for g directly, and you get this nice result. So this is what g is going to look like. And I'm going to show you why we know that this is also a valid CDF. It fulfills all the requirements. But just take a look at this first. So it's going to depend on the steady state rate of unemployment. And we know what that formula is, so we could plug that in if we wanted to. But just to keep fixed ideas, this is how we got it. If we want to do more with this, we could plug in for U star. We know what U star is. We know what 1 minus U star is. And if we do that, we can cancel some stuff. But right now, just keep your eyes on this formula. You can see that alpha 1 is important and alpha 0 is important. Those are the incidence rates. Okay? And this is determining the shape of the observed wage distribution according to Burdett and Mortensen. I love this model. It's really clever because I'm going to use that distribution now and go backwards. I'm going to go backwards because this has if this is an equilibrium, this has an implication for the way firms behave when they try to get workers. Right now we haven't said where the offer comes from, but when we do that, this is a nice place to start. Okay? Okay, so, but let's go slowly and check. Is this okay? Is this a CDF? Because we know what a CDF has to have. It's a probability law, if you like, and we have to make sure that all the valid requirements are met. Okay, but if I substitute for U star, I can make this thing look a little bit more attractive. You can see it's really a function of F. It's just a convolution of capital F. So you give me the normal distribution, the Gaussian or beta, whatever you want, and I can plug it in here and I can get the model predicts very clearly this is what the G is going to look like. But for a lot of people, it's not very satisfactory because it doesn't really tell you where the F comes from, right? And that's why search and matching is such a cool thing to think about. So how do we check? What are the requirements? Everybody knows this, right?
It's to be between 0 and 1.
Okay.
And non-decreasing.
Okay. Non-decreasing. The endpoints we can pin down. It's a CDF. So at the base of the support, there should be nothing. Right? So G of 0 has to be 0. That's by construction. And then a G of, at the top, a W upper bar, it's going to be equal to 1. Now, if I take this example where I just assume that the wage offer distribution is not just got a upper bound W upper bar, it's 1, comes from the unit interval. It's a great way to sort of train your mind to think about this. So think of a uniform distribution distributed on the unit interval. Uniform distribution distributed on the unit interval. So it's the easiest distribution you can imagine, right? So little f of w is equal to 1. And f of w is equal to w. So you can plug it in, and you get, still not completely pleasant looking, but it's pretty attractive, okay? Right, it's got a part that depends on the tension between W and WR. It also depends on the whole spread relative to the reservation wage, and it depends on these incidence parameters. Let's look at it carefully. This is a CDF. Well, you can look and you can see that it is. The lower bound is WR and the upper bound is 1. And G of 0 is equal to 0, G of 1 is equal to 1. And you can take the derivative of that. First derivative of G is little g by definition, and that thing is always positive. It might actually, yeah, I think it's always positive. It's not just non-negative, it's actually positive. Okay, so nice exercise for you to play with. It's just an example. But it's kind of an instructive example. You can even solve for the reservation wage directly. You can actually solve for it. Usually you have to ask your computer, plug in a distribution, and let it do some numerical approximation, numerical solution. But in the case where they're different, you can actually solve for it, and it looks like, looks beautiful, right? It looks like it's got a little bit of a logarithm in there. But why is that? Well, it's because you have to do integration by parts to get the answer. And integration by parts is always involving integrals of things like 1 over x, 1 over w. So that looks like a log function. And anyway, it's still not a closed form for WR, but it's easy to solve numerically. So I guess I misspoke. We can get a very crisp form for the reservation wage formula, and it leads to this still non-closed form solution for WR, but you can guess that pretty easily. Or you can use numerical approximation to approximate it. Okay. So now let's take the following example. Suppose that the incidence of on-the-job offers and off the unemployed offers is the same, and we'll just call that alpha. In that case, we know the reservation wage is equal to the unemployment income term, B. Okay, so we can derive that, and it looks like this. And we can also take the same derivatives we did before. You see that it also still holds, and you can actually plot it. It looks like something like that. You can see that the wage distribution looks a bit strange, doesn't it? I mean, it stochastically dominates F. G stochastically dominates F. That's an implication of the theory. But it looks like we're going to, it doesn't look like a normal distribution. So one of the problems with this theory is possibly that it doesn't always generate a normal distribution without doing more to it. You have to have some more heterogeneity in the model because we know that the wage distribution is, the log wage distribution looks sort of Paretian, normal, approximately. It doesn't look like this. Okay, but still, it's a nice place to think. I'm going to use, I think that the next part of this hour will be spent trying to use what we've learned to see if we can endogenously generate this F. Because the F has been taken as given from the very beginning. So before we do that, let's summarize. And again, this is just to remind you that we're always thinking about F coming first, G coming as an implication of the theory. The theory is, I think, fairly indisputable in the sense of, if you think workers have this level of rationality where they can think about a recurring event and they can use recursive methods to solve it, then you're going to get something like a reservation wage strategy, and therefore you'll have to think of things like this. And we just have to solve, which solved quite easily. And that's a nice starting point. So we're going to take this example of where the arrival rates are the same. And again, now you have to think about, where does this arrival rate come from? Does it come from people's intentional behavior? No. In this model, it's not. So it's not directed search, it's not directed intensity, but it's a starting point. Because we know you could endogenize alpha. We did that earlier in the course. Okay, so take this very simple example, and then we're going to ask, where does this F come from? Could we actually think about it? And that's what the contribution of this paper is, this Burdett and Mortensen paper worth looking at. Okay, and the context is a very old idea. It's really old, 50 years plus. Okay, so this is before I wasn't even a teenager yet. So, Peter Diamond is the father. Who is Peter Diamond? It's not Diamond and Divik. It's a different Diamond. You all took IAMA. Well, you didn't, but
The diamond model?
yeah, that diamond model. But what was that diamond model? Do you remember? Actually, you're still in the course. You better learn it for the final. Does anybody remember what the diamond model is? It's on the tip of your tongue.
It's a growth model?
Yeah, it's kind of a growth model, right? It's an OLG model, overlapping generations with capital. It was really clever, but so Diamond is all over the place. He's an amazing guy. He's written papers in every imaginable area. This is about search theory. Okay, so he was like working in the diamond mine with the OLG model, showing how if you introduce capital into the Samuelson overlapping generations context, you actually can get a growth model, right? You can actually show that you can have growth that's efficient or inefficient, dynamically inefficient. This idea is about how can we get a distribution? So this is he posed this as a paradox. He basically said, if you have a labor market where workers can talk to each other, or workers can just sample a lot, and even if they don't talk to each other, in some sense, eventually we're all going to know where the employers are that pay the high wages. And we're just going to go there. Doesn't make any sense to pay low wages, right? So in a world where there's perfect information and no frictions, and then he kind of danced around this idea. He didn't really actually show the frictions matter, but he worked on frictions. So he poses as a paradox, and I think Burdett and Mortensen actually solved it 20 years later. Actually, only 17 years later, and then it took another 10 years to get it published. Okay. In the same time, workers are looking for the best wages. How do firms behave? Well, they're not stupid either. I mean, they're going to try to pay low wages, but they may not get anybody. And if workers find out that, what's the point of trying to pay low wages? So why do we pay low wages? Why would a firm do that? Because they can get away with it. Okay, now I'm going to ask you, why could they get away with it? Why could Walmart get away with paying low wages? Or why could, Subway pay low wages?
Because people take the job.
You're dancing around the same way.
They usually have a lot of vacancies.
Maybe they have some market power in the region.
Yeah, okay, but where's the market power come from? Where could it come from? Well, it could come from being large, like Walmart. You just own the whole, you own the only employer in town. Take it or leave it. But the world doesn't look like Walmart, especially here in Germany. This is what the course is all about.
Frictions?
Yeah, frictions. It's about friction. So you're in the bathtub, you bump into someone who is offering you a job, okay? You could say, nah, you're paying me this last job. But you could also say, well, it's better than nothing. It's maybe better than B, or maybe it's better than B, even though it's lower than B, because it gets me into a better offer situation. It's the friction. It's all about the friction. The friction creates everything. And that's what... And that's why the firm actually has some freedom, or could have the freedom to pay a different wage. The firm could pay 50 euros an hour, it could pay 20 euros an hour, it could pay 10 euros an hour. And that's going to have implications for the firm's profits. It's going to have implications for the profits, expected profits. So the key innovation in this paper was that they thought maybe the firm, as a wage poster, a wage setter, actually has some freedom. When the worker shows up, it can say, well, I'll pay you 10 euros an hour. Take it or leave it. And the worker says, well, it's not very much money. But maybe if I get that job, I can get another job very quickly. That's one possibility, okay? Or the worker is, looking around and says, no, that's not going to cover my reservation wage. And again, workers are all the same in this model. So it's going to be a contest between acceptability and attractiveness, and the firm also has to think about how long is it going to retain the worker. Okay, so if a worker pays 10 euros and sticks to it, then chances are that we're going to lose that worker very soon because something else is going to come along. And that's what these guys have modeled. We've already modeled that. On-the-job arrivals is your ticket to get out of that lousy job. Okay, so the idea is the workers are facing, they're all identical, and they're basically arriving randomly at the employer, and the employer has to think of a strategy. And a strategy will be choosing a wage. That's the strategy set. You choose a wage. And then the survivors, the ones that have some profitability or common profitability across the distribution, will be the ones that are able to eke out the best profit, expected profit. So it's all about profit, right, in this model. And the workers are all the same. The firms are all the same. We can put the other stuff in there and get lots of action, but getting this right is already an amazing contribution. Okay? Yeah, Paul.
But that means the workers that are in unemployment, they take all the wages that are above the reservation.
Yeah,
So
yeah.
they can really think strategically in the sense that they might be offered like a wage that's only marginally above the reservation wage, and they say, well, I'm not going to take it, I'm going to wait for the next one.
Well, they could do that. I mean, that will be in their problem. I mean, but again, by definition, if it's above the reservation wage, it's better than not having a job. So being higher than the reservation wage means it includes all these bonus, the bonus of getting an offer that may be higher. So I can take this job at Subway, and then maybe in 5 minutes, some guy comes by and says, hey, I'm going to poach you. Okay, and that's in this model. It's all about alpha 1, alpha 0, comparing those. So if you think of this as a firm, if you think of each point on the support of the distribution as being a firm, remember we said there's no distinction between constant returns. So it's either the number of workers working for a single employer or everyone working at a firm paying a single wage. Okay, it could be that's a proxy for the size of the firm. Okay, but again, that's the problem with this model is there's no distinction because we have constant returns. There's no advantage to being a firm at all. A firm is just a collection of employment relationships. Not exactly realistic, but it's a good start because then we can add stuff. We can add other types of frictions that might be able to endogenize the firm distribution. But in this model, and they say that very clearly, there's no distinction. Okay. Questions? Okay, so you see, obviously, if the strategic, again, the firms are competing with other firms, so you think they have some strategic impact, but in the end, if they choose the reservation wage, they just declare it, and then that has implications for both turnover and for profits. It's bad for profits. We know that from the very beginning of the course. You pay high wages, you're not going to make much money. You'll still make maybe some money, you don't know, but you're going to make less money. So firms don't like to pay wages. That's one reason German employers are always complaining about Arbeitskräftemangel, right? Means they can't find any workers. Well, maybe they should pay higher wages, but they don't want to do that. So that's the way it is. And if they pay higher wages, they'll get lots of workers. Okay, so they won't have problems with turnover. This is why in the old days, working for Google was great because you got paid so much money that no one would ever poach you. And they knew that, and they could afford that. And now Google may be laying off workers. Amazon doesn't pay so well. So maybe that's why they're organizing unions at Amazon. But in any case, you can see all these different strategies involve different implications for profitability. Because if you have a low turnover, you'll have higher profits because you'll have workers on hand all the time. Because if you don't pay high, and someone poaches your worker and you lose the worker, then you're not going to be able to produce. You need workers to produce in this model. Okay, so the diamond world is different because the diamond world, everybody could sort of exchange information. You gather information, you know where the workers are, you know where the wages are the highest, so the workers go to the high wages, the firms try to go to the low wages, but they may not find anybody. In the end, an equilibrium is the competitive equilibrium. It's what we always praised in the Marshall paradigm. You know, I taught this in my labor course. It's what we love, right? It's efficient, blah, blah. But it is kind of the tendency. This is what Diamond was saying. If we don't have something going on here, we're going to end up getting a spike at the equilibrium wage. Call that a degenerate distribution because the mass is I mean, in the continuous world, it's infinite. I mean, it's probability of getting WR is equal to 1. So again, this is if workers really do have this reservation wage is equal to R, but this probably may not be an equilibrium, or it doesn't sound like an equilibrium, but is the worst possible outcome for the worker, right? But the workers don't have many options in this model, so that's probably why it's, yeah. So, ergo, frictions are key to, and that's what Burdett and Mortensen show us, right? That's the key, and turnover. So it's the frictions and the possibility of losing a worker makes it really, really interesting and makes the firm puts the firm under pressure because the firm thinks it's getting away with paying a low wage, but in the end it's losing workers and it can't produce. And that's exactly what we observe now. You know, if you look at the situation in Germany right now, it's actually not so great for the firms. This Corona business has put a lot of people in a different world where they say, I'm not going to wait on tables anymore. I'm not going to be a barista anymore. It's ridiculous. These people are breathing on me, and it's not pleasant anyway. I never really liked it before. The people are not very pleasant. Germans are not very nice to me, So I'm not going to do this anymore. So now, Starbucks and coffee fellows are complaining they can't find any people to work for them, right? So this is the interesting, and if you can't find any workers, you cannot sell coffee. So this is cafe down here at the Litfaßplatz that's been closed for weeks now because they couldn't find anybody to work for them. They had their family, and I think their family just sort of quit. So this is my interpretation. Yeah.
How come this is not a directed search model? I think it's very relevant. Like
It is.
If you are, as a firm, offering low wages, you expect as very, very few workers apply to fill the job. So this is what the directed search.
It is. It is kind of like a directed search model. And we're getting very close to it, but we're not there yet. Here, the directed part is the alpha, right? And the alpha is exogenous here. So it's like it's raining down offers. If you're unemployed, it's raining at a different rate. If you're in a job, you get it, but it's random. And you're saying correctly, and that's the next step. We'll talk about directed search in a couple of weeks. You can choose where you want to go, but it's not going to have incredibly negative implications for the fundamental idea, because it'll make it more difficult if firms try to get away with paying low wages, but they still will try. So in Germany, you have labor markets for immigrants, for example. They pay very bad wages. Why? Because the frictions are huge. The employer can threaten, I'm just turn you into the Ausländerbehörde or whatever. That's the worst possible case, where they can just make your life very difficult. You can create these frictions. You can create them. You can locate in some remote part of the world and train your workers there and build a factory there, and then they're sort of captive. So it's creating monopsony power may be an investment strategy. The workers, on the other hand, can invest in mobility, get better education, buy a car. So it's a battle. Sure, you're exactly right, but we've got to start small. You had a question?
You answered it.
Okay. Yeah. Good. All right. So now let's try to close the model. Workers are still risk neutral. They can accept and reject. And the workers do this knowing that the firms have different offers. But like I said, the alpha 0, alpha 1 basically mix everything up, and it's not really like a segmented labor market. So again, it's back at the time, it was very innovative. This paper is incredibly innovative. You know, it's sort of a breaking away, but we're still kind of thinking about directed search. And there's another paper by Wright in the Journal of Economic Literature that just came out on directed search. It's really amazing. It's an amazing survey because people have moved on, but we still have the fundamental ideas. Still, the fundamental ideas are the same. Okay. So the job offers have to be, if you want to have a theory of F, you have to have a theory of F that's consistent with G. Okay, before we took F and it yielded G, now we're going to take G and say that must affect strategically thinking workers, firms. Why would that be the case, Paul? Why would firms care about what's going on left and right in terms of F?
Well, if they know that the workers are aware of the distribution, then it affects whether the worker takes the job or not.
Yeah, if they again, the firm is deciding what W to set. And an equilibrium could well be a mixed equilibrium where there's many different firms offering very different wages, and in expected terms, the profits are very comparable. In fact, in this model, they're going to be identical. That's the way it's set up. But the firm cares about what the other guys are doing. Because if I offer epsilon more than the guy next to me, I'm going to be able to poach him because of this poaching process. Right? Some of my offers are going to rain down on that worker over there, and then they can come to me. But if I pay too little, I'm going to lose workers to that guy. So there's going to be some sort of linkage. So that's the strategic interaction in this. So wage posting is the key. We need some theory of how the firms can actually do something. They set the wage, and that's what's different from the usual. It's like monopsony model. So it's not the same, it's not a competitive model. It's literally the firms, and you could say, well, why do the firms get to do that? Why couldn't why can't I set the wage? Why couldn't we have worker wage posting? Well, in some markets you have that. If you're a lawyer and a top arbitrator, you might be able to set your wage, say, I'll do it for you, but you have to pay me this. Or if you're a movie star. But normally, there's much more substitutability, and, the question for me is always, why do we have the institution of wage posting and not some sort of mix, And maybe we do. Maybe that's what bargaining is about. You go in there and say, okay, what are you going to pay me? And they say, I'll pay you 15 euros an hour. And you say, well, how about 20? And then maybe that could be more of a Nash type of cooperative bargaining setup. But you might just have a situation where the workers are very powerful. So it's probably about power. But it could also be about institutions. Maybe it's just not polite. Maybe if for some reason that's an institution that has been accepted, that the workers don't try to haggle over wages. Or maybe there's a law that says you can't. I don't know. Yeah.
I was just wondering if we kind of base firm behavior on G, and we derive G from F, and then the firm behavior determines F, and we kind of going in a circle.
Yeah. Well, that's what economics is all about, general equilibrium. So you have, A and B conditions have to hold at the same time.
Okay, but where does the first G come from?
Well, I'm going to tell you.
Okay.
That's what we're doing. We're going to, the G comes from, the G we already derived. It comes from F.
Yeah, but
That's,
if F comes from, then it needs
No.
to be a start to all.
no, F is going to be firms looking at G.
Mhm.
G is going to determine F is going to implicitly be determined by G, but it's also going to be determined by F itself. Because in an equilibrium, firms are going to look left and right at F. Okay? But G will determine the consequences of their behavior in equilibrium.
Mhm.
Okay, so let's try it. Let's just try and see what happens. So again, it's repeating myself, but it's important to say this again, workers and firms are all the same, and the frictions are sufficient to get this thing going. So remember, we've made this easy for ourselves. We've assumed that alpha 0 equals alpha 1 equals alpha. This is a single parameter. So the rate of arrival and of these offers is completely indiscriminate. Now, to do this properly, at least according to Burdett and Mortensen, you want to think about impatience. You want to think about discounting, because if you're, well, in this particular setup we're going to look at, it makes sense for the firms to think of their wage policy as kind of an investment. And maybe they don't get a worker right away, but they may get a worker sooner or later. So they set a low wage. The expected profits are high if they can find a worker, but they may not find a worker immediately, but maybe they'll get one, and maybe they'll hold it for a while, and then they'll lose it again. So it's this trade-off. So to get the trade-off down, they have this intertemporal part, which is important. So you might say that sounds a bit inconsistent because the original model was in continuous time. Now we've got this discrete thing. Well, give them a break. It's okay. You can do it. It's just harder. It's harder to do it in continuous time for the firms. It's just nice to. And again, this is extremely innovative. And you can derive the search model in discrete time too. We already did that, so it's not a big deal. So again, this is relying on Rogerson, Scheimer, Wright. So we'll continually consider risk-neutral workers, risk-neutral firms, one worker, one firm. So productivity for having a worker in hand is constant. We'll call it Y. Okay, so in every period, if you have a worker, you get Y output, and you have to pay the worker W. And what's left over is your profit. Okay? And the only reason you'd want to pay a low worker is that you can get more profit. But you may lose a worker. So to start on this little tour, we have to think about what happens if you pay a wage that's really low or pay a wage that's really high. You can think about the probability of losing a worker. And this is one reason to do the continuous setup, because we can actually get a nice, we already have the equipment to do this, right? So you can imagine maybe the workers having this continuous time problem in their head, but they meet at discrete periods in some sort of bathtub, and then they get allocated somehow. Okay, so what's the probability of losing a worker? So you're an employer, you're paying this worker W, any W you like. So we will actually derive for every W, but just for any W, what is the probability of losing that worker? Well, you need that probability because you want to know, okay, I get that probability of losing the worker. 1 minus that will be the probability of having the worker, and then I can produce Y and make profit Y minus W. Okay, so that, again, it's expected value of profits is going to be a probability of retaining the worker and being able to pay wage W. And you can't cheat. You can't say, I'm going to pay you 50 euros an hour. Then when the guy says, I'll sign the dotted line, you say, I'll pay you 10. You can't do that. You have to keep your promise. Okay, so obviously if you look at that, you see that there are two things going on. There's exogenous blasts of lightning or strokes of lightning, and then this probability of separating to a higher paying job. And so the probability of getting an arrival, remember the intensity is alpha, and the probability of the arrival is better than what you have right now is 1 minus F of W. No reservation wage there, right? It's just I'm earning W, and if I get something more, the probability of getting that is going to be 1 minus cap F of W. So the sum of those two are the probability that I'm going to lose my worker, and 1 minus that would be the probability that I can keep him and produce. Clearly, if you look at this, you see that if I pay higher wages, I'm going to have a higher retention rate. Retention rate means I keep the worker, right? Lower probability of losing the worker because of getting an offer. So again, think of Google paying really high wages, which they do, and they have very little turnover because they're sure they want to keep these people forever. These people have already proved themselves, presumably. I don't know. Again, the world is more complicated usually, but just keep that in mind. Okay, so now suppose you don't have a worker. You think of this strategy that we talked about. Is you have to, for all time, you say I'm gonna be a high-paying firm. High-wage paying firm pays 50 euros an hour, and I'm just going to take the consequences. And I have to calculate those consequences. I can't go around shifting back and forth. You could, but it won't be optimal to do that because in the equilibrium, all these strategies, you're going to have the same expected profitability. That's the cool thing about this, okay? So what is the probability, if I don't have a worker, what is the probability of acquiring a worker? That means somebody has to leave somewhere else, either unemployment or getting paid less than W, and coming into my job. So you can figure out that as a sum of two probabilities. One is the probability of getting someone from a job that pays less than W. That's the second term. And the first term is the probability of getting someone from the unemployment pool. And the way the model is set up is that if the worker gets an offer unemployed, it's going to accept it. If it exceeds the reservation wage, it's going to accept it. So that's a constant. The reservation wage is equal to B in this setup. We've cooked it this way, just to make it easy. So that's the first term. The second term is how many people can I suck away from the competition that's paying less than what I'm paying right now? And that's the second term. So the sum of those two pieces is the probability of getting somebody if I don't have somebody. And remember, I can't get more than one person because I'm just a one-man guy, one-man operation, because this model has constant returns. Okay, so the probability of getting a worker is lambda divided by lambda plus alpha times 1 minus the CDF at the W that I've chosen, the one I chose. It doesn't have to be the reservation wage. I could try that. And you can see that just thinking about it, if I try that, I'm going to get what? I'm going to get basically, if I pay the reservation wage and there's an arrival of a person who's employed, he's not going to accept it, she's not going to accept it. It only works if the person's unemployed. So it's going to be exactly what we said. It's going to be lambda divided by lambda plus alpha. Okay, so that's the first part. We're still not done yet. Okay, now we're going to ask, can we calculate the profit for these firms? And again, these firms are kind of boring in the sense that they have the same productivity, and every period, if they have a worker, they get so much profit, and if they don't have a worker, they get nothing. So we can calculate in a very sort of, Holzschnittartige Modellierung what expected profits are. Having a worker. So look at this expression. The expected, again, we have to calculate the expected value of my profits given or conditional on two things: paying wage, W, and having a worker. If I don't have a worker, I don't have any profits. I have to get a worker first. But if I have a worker, I get this profit at the end of the period. This is just to make it easier for you to calculate the present value. It's going to be beta applied to the end of the period after I got the worker. After the worker and I have produced something, it's y minus W, and then there's a probability of losing that worker. And one minus the probability of losing that worker is the probability of keeping that worker. Okay, so that would be the second part, discounting by beta squared because it's 2 periods hence. And then you can write down the entire, it looks like a geometric sum to me. It looks like something we can actually simplify. And indeed, we can, and that's what the paper shows. It simplifies, because productivity is the same across workers, it's y minus W. W is my strategy. So my expected profit will be beta times y minus W divided by something like a discount rate, but it's higher than R. It's R, remember R is like 1 over 1 plus R is equal to beta. So that's just a simplification. R is equal to beta inverse minus 1. Okay? But look how beautiful that is. You can see that it's an increasing function of productivity, but productivity is constant. And you can see that it's kind of a double double-edged sword with wages. If I pay higher wages, I kill my profits, but I also raise my profits. I kill my profits because I have to pay more of my joint surplus to the worker, but the probability of keeping that worker is higher, and therefore the value of that worker is higher because I get that work for many periods, right? So isn't that beautiful? Yeah. Everything's relative. You had a question?
Yeah.
I had to put you off because I had to finish that.
When the firm posts a wage, then it doesn't really know which worker kind of gets hit by the wage, does it?
No, it's completely it's undirected.
And direct like the search for workers into like the unemployed pool or in the working people pool.
No, the idea is that these arrival probabilities are just, and it's the same, it's alpha. There's no alpha 0 and alpha 1. Now you can imagine, and we'll talk about that later, you can imagine choosing, and then you can ask, well, what's the disadvantage of, I'd always choose the, but you choose, no, but the problem is you have to consider what the other guys are doing. The other guys are also directing all their search in the unemployed. That will reduce, you'll have congestion and you'll have less success. So it's not the end of this model to allow that. Directed search actually can enhance some of the conclusions, but you have to, the cool thing about directed search is that it has externalities, right? If you're already there you're fishing for some fish, and I come in there and start fishing, then the chances of you getting a fish is going to go down, right? And that's exactly what Pissarides told us at the very beginning of the course. So it's, matching function, all the rest. Okay, so we've got this expected value, but it's only part of the story. This is the expected value of my profits, expected, if I post W. There's no guarantee. And if I don't have a worker, then I got to figure that one out too. So if I post W and I have a worker, then I'm not making any money today, but maybe next period I'll get somebody. So it would be the probability of finding a worker in that period times what I'll get next period. We already calculated that. So the model's it's seductively easy, right? The second term in this expression is exactly the term we derived last time, okay? So you can see that profits are not monotonic. And that's why there is an optimal sort of, there's not an optimal, but there's a potentially non-optimal policy of raising wages no matter what, or cutting wages no matter what. There's going to be a trade-off always. And then the firm will have to decide, what wage do I choose? So you could try to maximize this thing and set it equal to, set the first derivative equal to 0 and get some sort of local maximum, but that would assume that everybody else is not doing anything, that you're the only guy in town. And that's not right. The whole point of these guys in their paper was to show that if you look left and right, you have to watch out, right? So you're gonna, and they don't do it in a way that it's extremely complicated. You could imagine raising the wage might increase the scent of high wages and create directed search situations. I mean, you can add these things on, but right now it's just exogenous. The only thing that can happen is that you know that if I raise my wage relative to the other guys, I'm going to lose some of my attractiveness to people who are right next to me, who are paying a little bit less, and I will maybe gain some attractiveness to people who are paying a little bit more, but I'll make less profits. Okay, so that's the key thing we talked about. So ultimately, you're making this depend on what the other guys are doing in equilibrium, which is going to be the F. It will indirectly depend on G because of the equilibrium condition, but it's not going to, ultimately the assumption that these guys take is that no firm looking left and right has an incentive to change their chosen wage strategy. That's the trick. Okay, so they're gonna just apply that rule irrespective, and again, they're all the same ex ante, so how do they decide? It's kind of luck. I mean, if in equilibrium there's an IBM and there's a Hama, And they pay different wages, and they have equal expected profits. The high wage firms will have less turnover, but they'll have less profits for the capitalists, right? But the friction makes it happen. And if they pay low wages, they may get away with it in the sense of expected value, but they're not going to have a worker on hand all the time. They have to close their stores, close their doors. Okay, so the rest is just logic. We've already assumed that the arrival rates and unemployment and employment are the same, so we have alpha. And that implies the reservation wage is equal to B, so it's really easy to derive this. The probability of making any profits at all, if you have no worker and you offer exactly B, is not great. I mean, you'll have lots of money if you find a worker who just kind of stumbles in and says, I'll take it, because I'm paying literally epsilon above B. But in a second, that guy's going to be gone. Okay? And that's part of my problem. If I pay the highest, we'll have to derive what that is. But this is the endpoint that we can assume. If the equilibrium condition that Burdett and Mortensen take is that expected profit of a firm is the same across the entire distribution, for every point on F, the expected profit is the same, then we can actually derive F. Okay? We just have to find out what is the profit for this guy. Because that's going to be it's like the tail that wags the dog. I pin the tail down and then the dog is moving around. I just have to pin down one part of this. So think of a probability of the expected profit of, I don't have a worker, I post B, and then I can find out what that is, because we know that actually f of B at zero, at B equals, wage equals B is equal to 0, so the thing collapses to this very simple constant. It's a boundary condition, and all the other strategies have to have the same expected profit as this one. So this is like the worst possible firm from the worker's perspective, but it has great profits if you can find somebody. And that's going to be one endpoint of the offer distribution. And then the rest is just finding out, where does it stop? What is the highest profit? What is the highest wage I can pay and still have the same level of expected profits as this guy? And that's going to terminate the support of the offer distribution. That will actually cut it off. Start at B, and it's going to go to some higher W upper bar that we have to solve for. Okay, so if you think of that as a boundary condition and just apply that to any W that is valid in the offer distribution, has to obey that condition. The right-hand side is the expected profit of being a cheapskate, being the nastiest boss of all, that pays literally the lowest, epsilon higher than B. Okay? And then that's kind of that's the best we can do given the setup of the model. That's going to be kind of, it's a little bit like a free entry condition. It's an indifference condition across the distribution. So look at that. The left-hand side, you see F showing up, because F determines the attrition rate. If you pay a high wage, you lose few workers. If you pay a low wage, you lose a lot of workers per period. Okay, so we can solve for F, and that's it. Okay, it's a function of the arrival rate, of the destruction rate, and it's a function of this B, which is important. B is pushing up the bottom, right? So you can see already, this model, I don't think these guys intended it, but it's a great case for the minimum wage, because the minimum wage in this model has no efficiency effects at all. It doesn't change the frictions. It just pushes the distribution of surplus to the worker, right? Different people have different takes on that. Okay, but do we know this is a distribution yet? What do we have to do to find out to determine whether this is a distribution or not? The acid test, the litmus test for a, well, is it equal to 0 at B at the lowest point of the support at W equals B? Remember, that's part of the story. Yes, if you look at it. But we don't have an upper bound yet. We have to solve for that. Because a CDF has to be such that at the top, F of W upper bar is equal to 1. But we don't have a W upper bar yet. We have to derive it. So this model endogenously yields a maximum wage that a firm can offer as a strategy to which the firm is indifferent to offering the lowest possible wage in expected value terms. Okay, so again, we know that's the definition of what the upper bound of the support is going to do. It's going to mean that F of W upper bar is equal to 1, so we can solve for W upper bar. Because this model is so easy. It's just got a square root sign in it, right? So we just plug it in, and we get this term, which is, you can rewrite it. There are two different ways to write it. One is y minus this maximum possible offer, which yields the same profit level as being a cheapskate. And you can rewrite that as a weighted average of productivity and unemployment income. So I think that's very intuitive. It's a function of these fundamentals in the model. How productive are workers? How attractive it is to have a worker to produce with in the first place? And how attractive is it for the worker not to work? Those are the two things that determine the maximum wage that represents an equilibrium strategy for the wage posting firm in the Burdett Mortensen setup. Isn't that cool? Again, this is not exactly what a lot of people didn't. A lot of people were expecting more, but if you think about it, this is the beginning. Because I had nothing. I started with nothing. Workers are identical. Firms are identical. The only thing that makes it a little bit different is just this friction. And it's the friction itself. And there are two frictions. One is the arrival rate. So you can't get it all at once. You have to. It's almost like a sampling. You have to somehow physically be at different places at different times, or there's this inflow. There's a certain exogeneity of destruction of employment relationships. It's either due to retirement or just some disaster. The firm goes belly up, or the worker can't work anymore. Something has to split up the relationships, and that's enough to get this thing going. Okay? So, I'm done. Maybe too fast, but we'll repeat it. Key things to remember. What do we observe? What is actually offered? And these two differ. And it's very difficult to know what F is. It's almost impossible because workers are doing stuff behind our backs. We can't observe them doing stuff. We don't know what they've been offered. But we can infer it if workers have the reservation strategy. First order stochastic dominance, no crossing of the CDFs, and one is lying below the other implies dominance. First order, inflows into and out of, important concept. That's how we get G. That's how we're gonna think about G in all cases, because it's all about flows. And when those flows are equal to not changing anymore, we can derive steady state unemployment, like before, and imply the job-to-job turnover. Remember, the job-to-job turnover in the general model is very important. So if alpha 1 is greater than alpha 0, it's really attractive to take a job because you're buying into this intense, more intense offer mode, and that means you're going to move up. A lot of people say that describes the United States because it's very easy to fire workers in the United States. And what does that mean? Well, that means it's not a disaster to hire a worker and have a worker that just doesn't work out because And it's not just the United States. I mean, Denmark is another country that has very, very unregulated severance. But if you lose your job in Denmark, you fall into this very generous unemployment benefit system that pays like 80 or 90% of your net wage but then they start hassling you after a year and you have to accept job offers. So it's interesting. But just remember that job-to-job turnover is very high in the U.S. So if you look at the career path of young workers, the biggest wage increases occur in the first 5 years of their life. So and that's part of that is changing jobs, right? And that's not the case in this country. You can still get a raise, but you have to leave. And well, it's really hard. I've heard contradictory things on this, so I'm not going to go any further than this. But losing your job is not a disaster per se, and the attractiveness of taking a job quickly is not diminished. Yeah, you have a question?
Yes. Could you go back to the slide with the equation for the expected profit?
Okay, so which one would you like to see? This one?
Yeah, or one before, either one. So this basically says that if you increase your wage, your numerator.
You're the firm, right?
Yeah.
Yeah. If you raise the the wage you post, because you have to decide that once and for all. In an equilibrium, you have a W on your forehead and it says 50 or it has 25, and you have to stick to that. You can't change it after you've decided. If you pay a high wage, then you have a low periodic profit,
But also,
but you have less poaching.
yeah, less turnover. And essentially in drawing the CDF or the distribution for F, you want to make sure that ratio is equal? Is that what that the expected profit is the same?
Not this one alone, but the expected profit for, again, you can apply this condition to different phases. You can apply it to the pre-entry condition. So you decide, I haven't entered yet, I'm going to enter because I don't, and then you have to say, it's with some probability, if I enter with this wage, I'm going to have a worker right away or after the end of the period or not. And then I compare those. So those are going to be equal. Okay. And I think that's the condition we want to apply. So that's going to be, again, pinning this expected profitability down, not having a worker, and posting the worst possible wage we know the worker would just marginally accept. I mean, it's just flipping a coin. Because if you get your reservation wage, you're indifferent by construction. But the firm's profit is pretty easy to calculate. It's Y minus B, discounted, and then you have this incredibly low retention rate. So the discounting is going to be rather high. Okay, but it'll always be, that denominator is always going to be positive. And that's another reason for having this, standing on the shoulders of the old setup. Because 1 minus F is going to give us the retention rate. Okay, so I think it was a fantastic truncated lecture in the sense that I'm finishing exactly on time. And I hope you guys have a great week. Please go to visit Thomas and the section and find out what these other guys are doing that didn't show up today. Okay, see you.